discuss simultaneous linear and quadratic equation. At times, if we hear this kind of grammar, we'll be confused. Simultaneous means when two things are taking place at a time. So this topic is all about when you have a combination of linear and quadratic equation. You remember we first of all treated quadratic equations, after which we treated linear equations. Now we want to conclude the two topics by joining together the quadratic and the linear equation in what we call simultaneous linear and quadratic equation. And the first equation we want to use is to evaluate 2x squared minus y squared is equal to 7, equation 1. And x plus y is equal to 2, equation 2. If you look close, you find out that the first equation is quadratic because the unknown has an exponent of 2. The second is linear because the unknowns are on their own. They are not raised to any power. Now, if you have this kind of equation, what you do is try to make one of the unknowns in the linear equation the subject of the formula. And when you do so, you substitute whatever you have as the value of that one unknown in the quadratic. From there, you proceed down and solve the final thing you are going to have quadratically. Okay. The second equation we have here is x plus y is equal to 2. That is the linear equation, the linear aspect. Make either x or y the subject of the formula. Let's make x the subject of the formula. If you have x plus y is equal to 2, x plus y is equal to 2. That means only x is going to be 2 minus y. Now, substitute x is equal to 2 minus y in the quadratic equation. The quadratic equation is 2x squared minus y squared is equal to 7. Now you have discovered that x is 2 minus y. Wherever you see x, put 2 minus y in the quadratic. It's going to give us 2 into, let this be a bigger bracket, okay, 2 into 2 minus y, which is the value of x, and you have it squared. This is the form it's going to be. Then minus y squared is equal to 7. Try to remove the bracket. Remove the inner bracket first before the outer one. So we're going to have 2 into, what this means is 2 minus y times 2 minus y. That's the meaning of this. Minus y squared is equal to 7. Expand these two brackets. We're going to have 2 into 2 times 2 is 4. 2 times minus y will give you minus 2y. Minus y times 2 will give you minus 2y. Minus y times minus y will give you plus y squared. So we have succeeded in eliminating the inner bracket. It's now left with the outer bracket. Remember, minus y squared is equal to 7. Now remove this bracket now. 2 times 4 will give you 8. So we have 8. 2 times minus 2y will give you minus 4y. 2 times the next minus 2y will give you minus 4y. 2 times plus y squared is giving you plus 2y squared. Then the outer bracket minus y squared is equal to 7. Okay? Try to collect like terms now. Bring down 8. Minus 4y will give you minus 8y. 2y squared minus y squared will leave you with 1y squared is equal to 7. This is now close to a concrete quadratic equation, but we have to rearrange. Y squared have to come first, followed by minus 8y, then plus 8 will now be equal to 7. In a consolidated quadratic equation, the right hand side should be 0. That means we are bringing 7 into the left hand side, and we're going to have y squared minus 8y plus 8 minus 7 will now be equal to 0. Now, having this, you're going to discover that our equation, our quadratic equation becomes y squared minus 8y plus 1 is equal to 0. I looked very closely now to the question, and I discovered that I omitted something from the onset, which I'm going to correct now. This is not 7, it's minus 7. So in that regard, all the places we had that plus 7, we have to change them to minus 7. Because when I was looking at this thing being factorizable, I discovered it cannot be factorizable while it is supposed to be factorizable. All these things are minus 7, not plus 7. Yeah, all minus 7, minus 7. Now, this place, instead of minus 7, is now going to be plus, because when you bring minus 7 to the left-hand side of the equation, it will change to plus 7. And the value we are going to have here is going to be 15. Okay, we can factorize this. Provide 2 brackets and split y squared to the factors that made it, which is y times y. Find 2 numbers that have the product of 15 and sum of 8. 3 and 5. Minus 5 minus 3. Minus 5 times minus 3 will give you plus 15. Minus 5 plus minus 3 will give you minus 8. So if y minus 5 is equal to 0, that means y is equal to 5. Or y minus 3 is equal to 0. Remember, this is equal to 0. That means y is equal to plus 3. Because what we are solving is simultaneous linear and quadratic equation. Y has 2 values, 5 or 3. That, and also our x will also have 2 values respective to the 2 values of y. So we're going to substitute, first of all, that y is 5 in any of our equations. Let's take equation 2, because equation 2 is simpler. Equation 2 is x plus y is equal to 2. X plus y is equal to 2. But our y, let's first of all use when y is 5. That means x plus 5 is equal to 2. And if x plus 5 is equal to 2, that means x is going to be 2 minus 5, which is minus 3. On the other vein, if x plus y is equal to 2, and x and y is 3, that means x plus 3 is equal to, this is 2, sorry. That means x is 2 minus 3, which will give you minus 1. That means our grand answer is that y is equal to 5 or 3, while x is equal to minus 3 or minus 1. You can see that is what made this equation simultaneous, linear, and quadratic equation. You have double values for the unknown. This is question number 2. That question wants us to learn how to use graphs to solve simultaneous, linear, and quadratic equations. And that question says that we should draw the graph of x squared minus 2x minus 5 is equal to 0, and 2x minus 3 is equal to 0. This is the quadratic equation, and this is the linear equation. The graph of the two have to be drawn on the same axis, that means on the same page of your graph paper. And after you have drawn the graph, solve the simultaneous, linear, and quadratic equations algebraically, just as we did in question number 1. You solve it to get the roots. Now, B, that from the graph, we should find the roots of the equations and compare it with your result in equation 1. Yes, you can use the graph to deduce the roots. You can also solve algebraically and also get the roots. So what they are trying to tell us now to do is, when we solve algebraically first, we get the roots, the value of y and x, the two values. You know, in this case, there are two values for x, two values for y. Then when we also solve it with the graph, we also find the roots from there. I'm going to teach you how to find the roots from there. Then we'll now compare if it will be the same thing with when we had solved algebraically. That is exactly what they mean in A and B. Then C, say that you should find the roots of the equations. These are different equations. X squared minus 2x minus 2 is equal to 0. The second one, x squared minus 2x minus 5 is equal to 3. Now the last question said that we should find the minimum value of x squared minus 2x minus 5. Question number A. They say we should solve algebraically the two equations, the quadratic and the linear equations. The quadratic equation is x squared minus 2x minus 5 is equal to 0. The linear is 2x minus 3 is equal to 0. If you want to solve these two equations algebraically, you have to remove this 0 on two of them and replace the zeros with y. Otherwise, it will not work. Now, in the linear equation, try to make x, which is the unknown there, the subject of the formula. And when you do, you now use its value and substitute it in the quadratic equation. If you want to make x the subject formula in the linear, you're going to discover that 2x will now be equal to, you add 3 to both sides so as to cancel minus 3 here. You're going to have y plus 3. This is y plus 3. Now only x, if you divide both sides by 2, is going to give you y plus 3 all over 2. So this is the value of x from the linear equation. Now substitute this value for x in the quadratic equation. Then you are going to have, instead of x squared, y plus 3 all over 2 squared. So we have y plus 3 all over 2 squared. Then minus 2 times, instead of x, y plus 3 all over 2. So we have y plus 3 all over 2. Then bring down minus 5 is equal to y. Remove brackets. What this means is y plus 3 into y plus 3 all over 2 times 2. That's the meaning of this. Minus, you can cancel this 2 and cancel this, and use this minus to multiply out the numerator. Minus times y will give you minus y. Minus times plus 3 will give you minus 3. Then minus 5. This one is equal to y. I want to multiply out the numerator here. Y times y will give you y squared. Y times 3 will give you plus 3y. 3 times y will give you plus 3y. 3 times 3 will give you plus 9. All over 2 times 2 is 4. You have minus y, minus 3 minus 5 is going to give you minus y minus 8 is equal to y. At this juncture, bring in y from the right hand side of the equation to the left hand side. Remember, it is going to change to minus y. So we are going to have y squared plus 3y plus 3y will give you 6y. Then plus 9 all over 4. Then minus y minus 8 minus y. This one is equal to 0. Now minus y will give you minus 2y. So we are going to have y squared, I'm copying down this, plus 6y plus 9 all over 4. Then instead of minus y minus 8 minus y, you have minus 2y minus 8 is equal to 0. I want to make these things fractions, because we're going to find the LCM now. The LCM of 4, 1, and 1 is 4. Draw a line across the normal arithmetic. 4 divides 4 is 1. 1 time the whole thing you have there will give you the whole thing you have there, which is y squared plus 6y plus 9. 1 divides 4 will give you 4. 4 times 2y is going to give you minus 8y. 1 divides 4 is 4. 4 times minus 8 is going to give you minus 32. Everything is equal to 0. Now this 0 is 0 all over 1 in fraction form. If you cross multiply, discover that 4 times 0 is 0. That means you will now have y squared plus 6y plus 9, all the things in the numerator, minus 8y minus 32 is now equal to 0. This 1 is multiplying all this to give all this. 4 is multiplying 0 to give 0. Next thing we have to do here now is to collect like terms. 6y minus 8y will leave us with minus y, minus 2y. So we're going to have y squared minus 2y after we have dealt with this. Now 32 minus 9 is going to give you minus 23. And is 0. I hope you know what I did between minus 32 and 9. It's just like saying put that minus, subtract 9 from 32. If you subtract 9 from 32, you get 23. So this is now our grand quadratic equation. We are going to use the formula to solve this quadratic equation because it cannot factorize. The formula says y is equal to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. I want to be prudent with our space. Very soon we are going to clean off this and continue the solving of our quadratic equation. In this case, our a is equal to the coefficient of y squared, which is 1. Our b is the coefficient of y, which is minus 2. And our c is the constant, which is minus 23. Please, I would like us to clean up here and continue. We have to just manage our space. I want to copy down this quadratic equation, this quadratic formula, and this here. And now remove all this. All those processes, if you want to go back to them, you just rewind your DVD. You go back to them. You can write them down on a paper so that you'll be able to follow up as I'm continuing. So I'm going to copy down this here, clean up this, and continue the solving till the end. So what I have there is y squared minus 2y minus 23 is equal to 0. That is our quadratic equation. And our quadratic law or formula is y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now already we have found out that our a is the coefficient of y squared, which is 1. Our b is the coefficient of y, which is minus 2. And our c is the constant, which is minus 23. So I'm going to clean off all this other side now. Now begin to substitute these values in our formula. So we're going to have our y is going to be equal to minus b, and our b is already minus 2. So we have minus into minus 2. Then plus or minus the square root of b squared means minus 2 squared. Then minus 4 times a. Our a is 1 times c. Our c is minus 23. All divided by 2, so 2 times 1. Begin to simplify. Our y is equal to, if you open the bracket, minus times minus will give you plus. So we have 2 plus or minus the square root of minus 2 times minus 2 will give you plus 4. Minus 4 times 1 is minus 4. Then minus 4 times minus 23 is going to give you plus. 4 times 3 is 12. So write 2, raise 1. 4 times 2 is 8. Plus 1, 9. That means minus 4 times minus 23 is giving us plus 92. Divided by 2 times 1 is 2. We are progressing. We're going to have our y is equal to 2 plus or minus the square root of 4 plus 92 is giving us 96 all over 2. Square root of 96, 9.7979. So let's take it to be 9.8. So we're going to have that y, let me continue here, y is equal to 2 plus or minus 9.8, the square root of 92 approximately to 1 decimal place, all over 2. That means values of y are either y is equal to 2 plus 9.8 all over 2, or y could be 2 minus 9.8 all over 2. In the first case, this is 11.8 all over 2, 5.9, almost 6. This is going to be 9.8 minus 2, 7.8, that is minus 7.8, then divided by 2 is giving us minus 3.9. So these are the two values of y. Now that we have discovered the two values of y, we have to substitute it in our linear equation. Even if we do in our quadratic equation, we get something, but let's use linear equation that is simpler to find the value or the corresponding values of x. Our linear equation is 2x minus 3 is equal to y. 2x minus 3 is y. 2x minus 3 is 0. You have to change this 0 to y. In the initial part of the solving, I told you, you must change it to y before they can work. Now, you have found that y is 5.9. Let's see what the corresponding value of x is going to be when y is 5.9. So we're going to have 2x minus 3 is equal to, instead of y, put 5.9. 5.9. Add 3 to both sides. You will eliminate minus 3 from the left hand side. And on the right hand side, you have 5.9 plus 3. 2x is giving us 5.9 plus 3 is giving us 8.9. That means only x will be 2 divides 8 is 4. Nothing remaining. Put point. 2 divides 9 is 4. Remaining 1. Put 0 at the 1 to be 10. 2 divides 10 is 5. That means x is 4.45 when y is 5.9. The second value of x, we'll get it from x squared minus 3 is equal to y when y is minus 3.9. So now have 2x minus 3 is equal to, instead of y, minus 3.9. 2x, if you add 3 to both sides of the equation to eliminate minus 3, you're going to find out that in the left hand side we left with only 2x. while on the right hand side you have minus 3.9 plus 3. 2x is going to be equal to, what this will give you is minus 0.9. If you subtract, you just like put minus, subtract 3 from 3.9 to give you minus 0.9. Then only x, dividing both sides by 2, will give you minus 2 divided 0 is 0. Good point. 2 divides 9 is 4. Remainder 1. Add 0 to the 1 to be 10. 2 divides 10 is 5. That means that when y is 3.9, x is 0.45. This value is very important to us. I am going to write them down after I must have cleaned up this, because this value we have here, that x is 4.45 when y is 5.9, x is 0.45 when y is minus 3.9, is going to correspond to where the quadratic curve and the linear line will meet themselves, the points of intersection of the quadratic curve and the line of the linear equation. They are going to correspond to these values we have. So when I clean the board, I'm going to write those values and put, or maybe on our graph paper where we are going to plot the graph, you will discover that we are going to still get the same answer when we plot the graph. And that is exactly why the examiner said that when we solve the simultaneous linear and quadratic equations algebraically, we should also compare it to what we get when we solve it using the graph.